How many coordinates do you think lie on this line? Not just 3 that I have marked, but every coordinate. If you notice the pointed arrows at both ends, they indicate that this line can be extended in both the directions. If your answer is 100 coordinates lie on this line, what if I extend the line? And if your answer is that there are 1000 coordinates that lie on this line, what if I extend the line even further? So that means on a line, there are infinitely many coordinates. Now the real question is, what if I ask you to write all those coordinates? Seems impossible, right? But what if I tell you can do that? Think of it this way, that suppose you have a calculator and I, as your friend, keep coming to you every time I need help with calculation. So I may ask, can you tell me what is 8 times 5? I may ask, can you tell me what is 4 times 3? Right? Now, it may be irritating for you that every single time I have a question, I am coming to you and asking for the solution. Rather than giving me answers every single time, which you have to do forever, what if you gift me the calculator? So you gifted me infinite number of answers. You gifted me every answer that I want in the future also. So that kind of phenomena we are going to use here. Rather than writing every other coordinate, what if we have something powerful machine here which we can give or write so that we can generate whatever coordinates that lie on this line. That is what we are going to do here. So in a way, what we are using here is that we have a machine. We can call it, this is a very powerful machine that we have. Now we'll write this kind of machine. This machine will help us write all the coordinates that lie on this line. As long as you want to, you can generate as many coordinates as you want. Correct? Now this particular machine that I'm talking about is what called equation of line in mathematics. Equation of a line. So equation of line is a mathematical rule that helps us write as many coordinates as we want. Now, before we understand that mathematical machine or equation of line, let's first understand the system in which that works, right? You might have seen something like this, but I'll quickly refresh whatever we've studied till now. So earlier we used to have one single number line and numbers are plotted on it, right? So in this one single number line, I can move left and right. Then people thought that what if I want to travel up and down as well? So we created two number lines. One is a horizontal number line, and this horizontal number line is called x-axis, and this vertical number line is called y-axis. Correct? And the combination of x and y-axis together is called Cartesian plane. So whatever we are dealing in this chapter is done on this Cartesian plane. Whatever lines we are plotting, whatever coordinates we are plotting are done on this Cartesian plane. Now, on the Cartesian plane, we don't plot one single number, we plot coordinates, and coordinate has two values or two bit of information. One is x coordinate and the second one is y coordinate. If you see that I've plotted A, whose coordinates are 2, 3, so you can say that 2 is the x coordinate and 3 is the y coordinate. That means that I've traveled 2 units in the right direction and 3 units in the up direction. Correct? So these are the coordinates and we are dealing with these kind of coordinates. The bit of information, they are in the bracket, ordered pairs separated by commas. Perfect. Now, in the beginning, we said that we have a Cartesian plane on which a line is drawn, and a line is made up of infinite points and every point has a coordinate on the Cartesian plane. Correct. And a line has therefore infinitely many such coordinates. If I want to write all those coordinates, I can give you an equation of line. So equation of line is basically all the coordinates combined together, compressed together, right? If I give you equation of line, you are able to generate as many coordinates as you want to. Right. Now the real question is that how do I write such equation of line? How that equation of line looks? So, before we dive deep into what equation of line is, how do we build such an equation? Because it's so powerful, we want to build it. I want you to give a perspective about what you already know, right? You might have seen these kind of things that we are going to do right now. I just wanted you to focus on these things first, right? Now, what if I write something like this on the screen? Now you say that this is kind of a polynomial I've written, right? And it is a linear polynomial because the power of this x is 1, and we can say that the degree of the entire equation is 1. So degree is 1. Therefore, this is a linear polynomial in terms of x. Polynomial in terms of x, 2x plus 3. Correct? Now, if I say that x value, you might have studied also values of polynomial. If I say that if x is 0, find p of 0. So you can say that p of 0 is nothing but I just have to replace x value with 0. It becomes 3. If I say that find x equals 1, when x equals 1, find p of 1. You can say that the p of 1 will be 2 plus 3, which is 5. Right? You can go on do this, right? X value is 0, 1, 2. Then your p of x technically means p of 0 is 3, 5, and p of 2 is 7. Correct? Now, imagine you have a juicer, right? Imagine you have a juicer, and in the juicer you are giving a solid fruit. What's coming out is the liquid form of that particular fruit. Correct? You are giving your solid. What you're getting is a liquid one. Correct? We can say that this is my input, and there is corresponding some output that I'm getting. If you're giving apple, obviously you're getting apple juice, right? So your input and output, right? You are giving solid fruit and you're getting liquid output. Correct? Now, what if you are not storing that output? You need a jug, a mug, a cup to store that juice that is coming out of the juicer. Correct? You need a storage. That is what we need here in the linear polynomials also. If I'm saying that I'm giving x value, as 0, 1 or 2. See, I've given x value as 0, 1 and 2, and I got some output also 3, 5 and 7. Right? I want to store it somewhere. So this is my linear polynomial. I want to store the output that is coming out. So I will introduce another variable. Let's call it y. So whatever answer I'm getting, 2x plus 3, this is a linear polynomial, 2x plus 3. Whatever answer I'm getting, once I substituted x value as 0, 1 or 2, that means my input is 0, 1 and 2. The output, I'm storing it in a variable called y. That is 3, 5 and 7. Right? So whenever x value is 0, y value is 3. Whenever x value is 1, y value is 5. Whenever x value is 2, y value is 7. Correct? So I can say that your linear polynomial, I've just converted your linear polynomial into a linear equation in two variables, because there are two variables. One is x, which is your input variable, and y, which is your output variable. Correct? Now, if you see that this x and y table that I just created is not a numbers, they are beautiful information. If you see, x value is 0, y value is 3. They are ordered pair. I am not saying that whenever x is 0, y value can be anything. No, y value has to be 3 only. Whenever my x is 0, y value is 3 only. Whenever my x is 1, y value is 5 only. So they are ordered pairs separated by comma. That is what we did in the Cartesian plane also. We said that on the Cartesian plane, we are plotting coordinates. And in the coordinate, we have two values. One is x coordinate and another is y coordinate. So now, technically, you got one coordinate, which is 0, 3, another is 1, 5, and another is 2, 7. And now, as long as you keep on giving this particular thing, x value, suppose if I give x as 4, you will get some y value also, right? If I give x value as, let's say, 5.2, you will get some y value also, right? As long as you're giving this particular thing x value, you are getting y value. Obviously, that is how things work in real life also. If you're giving some input, you will definitely get some output, right? So that is what we are doing here. So that means this particular thing is giving you coordinates, is generating coordinates, you can see. So this is the only powerful machine we are talking about. And we can say that this is an equation of line. Why equation of line? If you see that if you plot these coordinates on the Cartesian plane, I've just drawn the first quadrant. This will result into a straight line. Why? Because we started with linear polynomial. I converted that linear polynomial. Not basically conversion is not a correct word, I would say. I've rewritten that linear polynomial in terms of linear equation. Right? And linear itself has a word line in it. Line equation. Equation of line equation. So linear equations, equation of line, the same thing, right? So linear equations obviously generate coordinates and result in a straight line on the Cartesian plane. So these three coordinates that we just got, if you plot them on the Cartesian plane and join them, they'll give you a straight line. Right? So technically you started with linear polynomial and you plotted it on the graph, you got the line. That is what a equation of line looks like. Right? So the only idea that we have for this particular part is that I wanted to show it to you that you are already in touch with this rule. You're already studying it. The only part that you did is till now is that we have the equation. We were given the equation like if I give you y is equals to 2x plus 3, if I give you 2x plus 4y equals to 5, let's say. This is also a linear equation in two variables. You give x value, you will get y value. You will give x value, you will get y value. So that means this equation will also generate coordinates. And if you plot those coordinates on the Cartesian plane, you will get a straight line. So all of these are the equation of lines. Till now, you were given equation of line, and using equation of line, you plot a line on the graph. Correct? That is what we were doing till now. Now, in this particular topic or chapter, what we are doing is we were given a line or some information about line, some information about the line. What kind of information? What if I tell you there is one, I'll tell you that 1,2 lies on a line. You need to find out that line. I can give you some information. I can say that I'll give you two coordinates, find out the equation of line. So I'll give you line, some information about the line, but you have to find the entire equation. Correct? That is what we are doing here. Till now, you were given equation. You need to find out the line. You can do so by substituting x value and you will get corresponding y value. You plot them on the graph, you get a line. Now, line will be given. By line, I mean some information about the line. They will give you one coordinate, two coordinates. That depends on the question to question. What kind of information they are giving us about the line. They'll give you information about the line and they ask you to generate the equation now. That is what this particular entire chapter and this topic is. So equation of line, I hope you understood what equation of line is. So that is what we learned in this video. We started with a very simple question of how many questions lying on a line, and we said that there are infinitely many coordinates. And if somebody asks me to write all the coordinates, I can do so by writing an equation of line. So equation of line basically gives me all the coordinates that are lying on that particular line. Now till now, what we were given equation of line, and I can create a line. From that equation of line, I will substitute x, I'll give x as input, I'll get y as output, I get coordinates. From equation of line, I'll generate coordinates, and those coordinates can further be plotted on the Cartesian plane and they'll result into a line. That is what we were doing till now. But now we are reversing the game. Somebody will give you some information about the line. They will give you coordinates. You have to, take those coordinates and now generate or build the equation of line. Right? We then saw linear equations. We started with linear polynomials, linear equations. So linear polynomials can also be written as linear equations when we introduce a separate variable. We call it output variable to store whatever output we are getting from the input. When we are giving x values, we are getting some output. For that storage of output, we introduce the another variable y, and that linear polynomial gets converted into linear equation. Right? Linear equations are nothing but line equations. We've seen that linear has a word line in it. So line equation is basically equation of line only, because that helps us generate coordinates, and then coordinates help us generate line. Right? I hope this was fine. Yeah. So if today felt a little different because we didn't straight jump into the textbook questions, so that was completely intentional. We first need to understand the idea behind what we are going to study. So that is what we did in this video. And I hope this video helped you out in some way or the other. And that's it for today. And I'll see you in the next one. Please remember, maths is easy.